Well, to mold and cast a clear pine cone using the ECOFLEX 0030 liquid silicone rubber. Now, this project was given to me as a bit of a challenge. I was basically given this ginormous pine cone and was asked if I could make a mold and do a clear casting in that. And to tell you the truth, I wasn't 100% sure that it's possible due to its shape and all the deep crevices and pockets. But I wanted to try it out. It was definitely a challenge, and here you can see the results of that project. So we're quite successful. Now let me jump into this project and explain and show you how I've gone about doing this. The first thing you need to realize is that a model of this configuration that is very fragile will probably be destroyed and not survive the molding process. And as you can see here, that's exactly what happened to me. I had to actually break the model in order to extract it out of the mold. Now, the second thing to keep in mind is our end goal. Where do we want to be with this project when it's finished? And in this case, we're trying to make the castings that are going to come out of the mold glossy and shiny. And for that reason, we need to seal the pine cone itself. The petals are quite rough in texture and will soak in a lot of the material, the silicone. So to prevent that and to give us a glossy finish for our castings, we're going to seal the pine cone using some epoxy coating. And for that, I'm going to be using the XTC 3D. Now, the XTC 3D is designed as a coating product, and because it's an epoxy base, I know we'll leave that finish very shiny and smooth. But the XTC itself is a 2-to-1 mix ratio by volume, so we don't need to use a gram scale unless we want to. It does have a working time of about 10 to 20 minutes, depending on how thick you're applying the material, and a full cure of 3.5 hours. Now, one thing that's really important to remember is that epoxies are mass sensitive, so you don't want to keep it in a small container where it's going to be in one single lump. You want to spread it out, and for that reason, I'm making this aluminum foil tray, and we're going to use that aluminum foil tray as a catch basing for the material we're going to apply to the pine cone. Now, we can go ahead and dispense our XTC 3D. I'm going to go ahead and dispense 2 parts of the A and then 1 part of the B. Now everything is going to get combined in a clean mixing container. As always, you want to scrape the sides, scrape the bottom of your mixing container, make sure that you incorporate those 2 parts thoroughly together. Now once you have that mixed, I like to get it out of the cup as soon as possible. Again, it's that mass concentration that we want to avoid, because it's going to start to heat up and the material is going to start to kick and catalyze. So I'm going to get it out of the cup by simply sprinkling it onto the pine cone. It also helps out because the epoxy coating can get into some deep crevices there. And once all that material is out of the cup, we can then proceed by focusing on the detail and using some of that drip off in the aluminum foil tray to bring it back and brush it back onto the pine cone. So now I'm going to go individually around all the petals and going to put a coating of the epoxy on it. Once the epoxy is brushed onto the pine cone, we can put it aside and let it fully cure for 3.5 hours. Now notice that I set the pine cone in a deli cup here, and the reason for that is that if any of the epoxy is still dripping off, it's going to kind of drift towards the center of the pine cone and cure there, rather than if we put it on the side and it starts to leak sideways, you're going to have a lot of drips along the edge of some of those petals, and that's going to look ugly in our casting down the line. So keep the bigger picture in mind throughout the entire process of where you're trying to go. The XTC 3D has now allowed a full cure for 3.5 hours. Once the epoxy coating has fully cured, we can go ahead and attach the model, the pine cone, to a working surface. Now this has to be secured thoroughly, so we're going to use a screw and screw this pine cone onto the working surface so that it cannot float up once we pour the silicone all over the model itself. Now, before we proceed to actually pouring any kind of material, you want to double check and make sure that you do or don't need a release agent. And here on the XTC technical bulletin, it does call for a release agent to be used before making a platinum silicone mold. So we're going to use the East Release 200. This is an aerosol can here that I'm using. And I'm going to simply spray the entire model from all the different angles and let that dry. Now, before moving on to the next step, we also want to apply a pour spout using some Sculptex clay in the middle. So that's where the material is going to pour from. But then we also want to add some air vents. All these little petals that are sticking downwards in this picture are going to be catching air and trapping air, creating air bubbles. So we're going to put little air vents there. These are mixing sticks that I broke up into small sections. I used some CA glue to attach the vents from the model, our pine cone model, to the working surface, the working board. Our mold box and support shell for this project is going to be this cardboard tube that we first need to seal. Cardboard is porous, so we're going to seal it using some sonite wax. We're going to pour the silicone in here and don't want this to stick. So apply the sonite wax and let that dry for about 20 minutes. Let it soak in. I'm going to come back and wipe out any of the excess material that's in there. So if there's too much of the sonite wax, wipe the excess off, and then we can proceed to adhering the support shell onto the working surface. And for that, we're going to be using some hot melt glue. Now, why is it important to have a support shell here? It's really easy to see, and as you can see here, the silicone is quite soft. It's very bendable, shapeable, so you can easily distort the shape of your casting by not having a support shell. Furthermore, the material can leak out on the side, so it's really nice to have that aluminum shell, support shell on the inside to keep everything tight, and then the cardboard to kind of help handle everything as a complete mold. For the molding compound for this project, I specifically used the ECOFLEX 0030, and the reason behind that is because it's very, very flexible, and I know that the crevices in between those petals are going to be very hard to get the mold off. But beyond that, if we take a look at the technical bulletin, the viscosity of the ECOFLEX 0030 is very low at 3000 CPS, which means that the rubber can naturally vacuum the gas, and it's easy to pour. Now, this product is a 1-to-1 mix ratio by volume or weight, but we're going to use the volume because it's much easier and is translucent in color. As far as your working time, you got 45 minutes of pot life or work time with a full cure achieved in 4 hours. Now, in order to mix enough material for our mold box, we're going to be using the mold making and casting calculator you can find on the Smooth On website. And here I'm going to use specifically the pour on estimator. And once I enter the dimension of my mold box and my model, it's going to give me an approximate amount of how much product I need for this project. And in this case, it's asking for about 15 pounds of total material needed. And since the gallon unit contains 16 pounds, I'm just going to go ahead and mix up the entire gallon here. Now, since I know already that I'm going to be using the entire gallon unit, I'm going to go ahead and dispense the part A and the part B directly into a mixing container. This is a 5-gallon bucket that we cut down. To mix a large quantity of material like this, I like to use the variable speed drill with a turbine mixer. It's of benefit to actually use a turbine mixer just because it's very fast. And then once I mix it, I'm going to still come back and scrape the sides and scrape the bottom thoroughly, just as if I was mixing by hand. So very important to scrape the sides of your container and scrape the bottom to make sure there's no unmixed part A or part B left in that container. Now the material is poured slowly into the mold. Again, 40 minutes gives you enough work time to mix and pour without having to rush through this project. And this process you see here is called needling, where you pour the material in a very thin stream, and that thin stream stretches the air bubbles and breaks them so they don't end up in your mold. Again, with this technique and the material that we're pouring being really low viscosity, doesn't need any vacuum degassing or pressure casting because the air bubbles are going to be able to naturally degas on their own. Now, before you walk away from a project like this that has a lot of material contained, we want to be absolutely sure that there's not going to be a leak down along the bottom of our mold. So therefore, I'm going to put a bead of the SKIN oil-based clay, and that's going to prevent any material from leaking out. Now, this has allowed a full cure for 4 hours before demolding. Now that the ECOFLEX has fully cured, we can go ahead and demold our project, starting with removing off the working surface, the working board, and then we're going to remove the actual mold from it as well. Now, to open up our support shell, our mold cavity, so to say, we're going to simply cut the cardboard tube using a razor knife. And don't discard this tube. This tube is important to keep. This is going to be our support shell for the mold, so put it aside. Don't throw it out. Now we're going to proceed to cutting the mold open. You notice here I'm doing a S-curve going all the way down. I'm using also a mold knife, which has a very specific blade to leave a key in the entire cut. But the most important part to understand about this process right here is that you need to take your time. This is a very difficult piece to mold, and all those little pockets of silicone now need to be cut open. You need to make a clean cut line down along the side of that mold. And now to finish this off, I'm going to remove the little air vents that we put in. And then I'm going to slowly massage the mold off of the object, off of the pine cone, the original. Now here you can clearly see another aspect of why I chose this particular material. It is super, super stretchy, and I'm able to stretch the mold basically backwards without distorting it. And here you can see how those slowly pop out. Boop, there it goes. That's half of it. We're going to remove the other half. But again, the molding material is so stretchy that we don't have to worry about damaging the mold by really working it to get that model or casting out of it. Freshly cast silicone has a lot of surface tension. And if we add a little bit of talc powder to the outside of our mold, it's going to eliminate some of the surface tension and allow the sections of our mold and support shell to easily move against one another. And then I'm going to wrap it in this aluminum flashing. And a lot of people ask me, why are you putting this in the aluminum flashing? Very simple. It's going to help me put the mold inside that cardboard tube easily, as you can see here. But furthermore, it helps me with the alignment seam line and helps me minimize that seam line by perfectly aligning it and kind of strapping it into the aluminum shim that wraps around our model. Now, I'm sure you heard me say that it's important to keep the end result in mind when you're doing these projects, and the same goes here as well. Now, before I went on making the big mold of the entire pine cone, I did a small-scale test where I tested the whole theory as far as my technique and the materials I wanted to use on a smaller scale. So I took a small pine cone, I made a smaller mold, and then I casted the material in it. Because the material that I wanted to cast into this is the crystal clear. And if you look at the technical bulletin for the crystal clear, it doesn't say that you can use the ECOFLEX for the molding. So in order to test my theory, I did a small-scale test and discovered that, yes, I can actually do this. Now, as far as which one of the crystal clear to go with, it comes down to the basic thickness and mass that you're making. So the pine cone that we're making has very thin petals. So I wanted to use something that's for that purpose. So for this, we're going to use the Crystal Clear 202. It's good to know that the Crystal Clear 202 has a 9-minute work time and a 90-minute demold time, while its mix ratio is by weight only. So we do need to use an accurate gram scale for this part of the project. Now, looking back at the technical bulletin for the Crystal Clear, besides the selection of the molding rubber, I do see at the bottom here that for best casting results, it's important or good to preheat the mold to 212 Fahrenheit for 4 hours to minimize any kind of defects in the casting resin. So fish eyeing, suckback, and such would be eliminated by preheating the mold and will give us much nicer surface finish. Now that our mold is ready for the casting process, we're going to put it in the oven and heat it up as recommended in the technical bulletin. And in the meantime, we can go ahead and focus on the materials, and that starts also with putting on a respirator. So the Crystal Clear is an industrial base product, so it does recommend to use a respirator, and that's exactly what we're going to be doing. Now we can go ahead and proceed to dispensing the part B and pigment the part B first, mix it in thoroughly, and then you can dispense the part A. Again, the part A is sensitive to atmospheric moisture, so we don't want to dispense it and leave it sitting on the counter for any time. So mix your pigments into the part B and then proceed to dispensing the part A. Once the components are dispensed, we can go ahead and mix them thoroughly. As always, scrape the sides, scrape the bottom of your mixing containers. You want to make sure that you incorporate those two parts thoroughly together so that you don't have anything that's not curing end up in your casting. Now, because this is a clear product, I like to double mix. So once it's all mixed, I'm going to transfer into a secondary clean container, mix it again, and then we're ready for the casting process. The mold is now taken out of the oven, it's set up, and the casting process begins. Now, what you're going to see me do here now is I fill up the mold about halfway, and then I kind of burp it. I spin it around, knowing that the material needs to make its way into some of those petals, and a lot of the air is going to be escaping. So again, we're going to pour the material into the mold, then we're going to roll it around, allow the material to go into all the detail, and then we're going to top it off. And you can repeat this process 2 or 3 times until you fill up the mold completely. Now, once the mold is completely filled, we can allow it a full cure for 90 minutes before demolding the casting. All right, now that our casting is fully cured, we're ready for the demolding process and see how well we've done. We're going to simply slide that support shell off. The aluminum shim is removed and we're ready to demold our casting. Now, as with the original, you want to go slowly. Understand that this is a very complicated casting and we don't want to break any of the petals off. So we're going to go very slowly in the demolding process. We're going to slowly massage and pull that mold off of our casting. Here again, you can see why it's really important to choose the right molding rubber. I knew that a lot of stress is going to be put on this mold, and I needed something that's very stretchy and will not tear very easily. So again, go very slowly when removing. Because this is a very complicated piece, the petals are very thin, I want to make sure that I get the complete casting out, and there it is. So we were actually able to achieve what we set off to. So here's our first casting out of that mold. It looks absolutely beautiful. And again, it goes to show you that with a little bit of thought and planning, even the most difficult projects are achievable. The coloring options are endless with the addition of the So Strong, Ignite, or UVO colors to give your castings a very unique finish. Now, if you got inspired by this project and you'd like to give your own projects a go and need some material, you can visit any one of our distributors around the world. So there you have it, a step-by-step procedure that I use to make a mold of what seemed to be the impossible object to make our project here a possibility. With a little bit of testing of the right product, I was able to make the right choice to make this project a possibility. Now, if you have an idea about what we should do next, let us know down in the comments below. If you like this video, hit the thumbs up button. Now, to keep up with our latest mold making and casting videos, remember to subscribe.